Okay, please turn in your study guide to topic chapter 19, question number 45. So there are chemical reactions that take place that exchange electrons, and these are called oxidation reduction reactions. So we need to quickly go through the following terms for question number 45. Oxidation, and reduction. Okay, so there's oxidation, which is a loss of electrons, and reduction, which is a gain of electrons. And then we have something called the oxidizing agent, reducing agent, that we'll talk about soon. So for number 46, what happens in a direct combination reaction? A direct combination reaction is where one atom or one substance loses electrons and one gains electrons. So for number 47, we're going to use this as an example. So we'll use this as our example of our balanced chemical equation. And it asks which element is oxidized, which one is reduced, what is the oxidizing agent, what is the reducing agent. So for these things, again, a way to remember oxidation is losing and reduction is gaining. We can look at it as oil rig. Oil rig stands for oxidation is losing, and we're talking about electrons, and rig is reduction is gaining. So that can help you out when you're trying to figure these things out. So first off, we need to go through and assign oxidation numbers to these things. Oxidation numbers we've covered when we talk about charges of elements on the periodic table, but we know that not all elements always have the same charge. Like copper, for example, can be a +1 or +2. So how do we decide what charge an element has? Well, there are some rules that we need to learn first, and then we will go back and assign oxidation numbers to these things. So first off, oxygen is -2. Okay, it always has a charge of -2. Group 1 elements always +1. Hydrogen, always +1. Okay? So those are the ones that we really need to focus on, are the oxygen, the hydrogen, and then we can figure out the other oxidation numbers. And the rule is that the sum of the oxidation numbers has to add up to 0. So sum of oxidation numbers, which are just charges, so for example, if I'm trying to find the oxidation number of arsenic and oxygen, the sum of these two oxidation numbers needs to add up to 0. By the way, we do not worry about coefficients when we are doing this. We're just strictly looking at the element and its charge, not the coefficients. All right, so let's apply these rules to assigning oxidation numbers for each element in this chemical formula, in this chemical reaction. Oh, one more rule I forgot to add. okay? They always have an oxidation number of 0. So an individual element or a diatomic molecule like oxygen, its oxidation number is always 0. So now we are ready to assign oxidation numbers. So arsenic and oxygen. Arsenic does not have a rule. So we're going to use the rule for oxygen to determine the charge on arsenic. So oxygen is -2, and since the sum of the oxidation numbers has to add up to 0, arsenic has to be +2. So we would say that arsenic's oxidation number is 2 + 2, oxygen's is -2. Now this oxygen is by itself, so it has an oxidation number of 0. Now we go over here to our products. Oxygen has an oxidation number of -2, so that's each individual oxygen has an oxidation number of -2, with a total charge, though, of -6, because there are 3 oxygens. So it's a -2, a -2, a -2. Therefore, to add up to 0, this has to be a +6, which means each of these arsenics is a +3. So if we were asked what the oxidation number of arsenic was, it's +3, but since there are 2 of them, the total charge is +6. So that's how you go about assigning oxidation numbers. Now, once you have done that, you can determine which element is oxidized for number 47, which one is reduced, and then we'll talk about the agents. So let's look at arsenic. Arsenic went from a +2 to a +3 on the product side. It went from +2 over here to +3 over here. Therefore, arsenic lost an electron. Remember, the more positive your charge becomes, the more electrons you have lost, because electrons are negatively charged. So since this was a loss of electrons, and oxidation is the loss of electrons, arsenic is the one that was oxidized. All right, then we look at oxygen. Oxygen went from a 0 charge to a -2 charge. This is a reduction in charge. That's why a gain of electrons is called reduction. But the more electrons you gain, the more negative your charge becomes, or the further reduced your charge becomes. So this is a gain of electrons, which means that it is reduced. So you cannot have oxidation without reduction. The electrons are given to one substance, and the other substance takes those electrons. So it is a give and take. It's not just losing electrons or just gaining electrons. Oxidation and reduction go hand in hand, they're a pair. Now, as far as the agents go, it asks you what is the oxidizing agent and what is the reducing agent. If you are oxidized, you are the agent that reduced something else. So oxidized, also known as the reducing agent. The thing that was reduced, which is oxygen, was the substance that oxidized something else. So it is called the oxidizing agent. So if you are oxidized, you are also known as the reducing agent. If you are reduced, you're also known as the oxidizing agent. Now, as for question number 48, it says to balance a redox equation, which you're not going to have to do, but you do need to know what this means. You must blank the increase and decrease in oxidation numbers. It's balance, okay? You need to balance the increase and the decrease of those oxidation numbers.